Yo, what's going on guys? Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms. And today's topic is going to be Infix to Postfix C++ program using a stack data structure. Yes, this is the practical side of Infix to Postfix using stack data structure. And if you don't know the Infix to Postfix conversion, please make sure to watch the previous two video tutorials in this course where we've discussed the rules and then we also saw the pseudocode which you can see on the right hand side. So we've discussed thoroughly these two things. That is the conversion of infix to postfix, and that is where the working was discussed. We also took some examples, and in this today's tutorial we're just gonna focus on writing a C++ program, that is the practical implementation, because a lot of times this part is left out and then it gets difficult for students to actually implement this in their practical exams. So please make sure you watch this video till the end, and with that being said, let's get started. If you're new to my channel, my name is Tanmay Sakpal and I do a lot of computer science and information technology video tutorials like computer programming, development, technology talks and a lot more on this channel. So if that's something you're interested into, then definitely subscribe and turn on the notifications to get the latest updates and never miss out on such important topics. Okay, so as you can see, I've already written a little bit of code. Let me just quickly explain to you what it is. So our goal is to take a infix expression from the user and to convert it into a postfix expression, and we are going to use a stack data structure. Okay, so in the int main, what I'm doing, I'm creating two strings, infix and postfix. If you don't know what is this string class, I have a separate video which explains C style strings versus C++ style strings, so you can go watch that. But basically we're just creating basic strings just like we do in Java or any other general purpose programming language. Then we say enter a infix expression, and we take that infix expression and store it in the string infix. Now here is where we create a stack data structure. Now if you're wondering what is this opening and closing angular brackets, this stack is coming from STL, which is standard template library, which is provided in C++, which has a collection of these predefined data structures and algorithms and different functions which we can directly use into our code. So on the top also you can see I have said hash include stack. So basically I'm including all those stack related functions and stack related classes and templates into our programs. Now if you don't know what is templates, I have again another tutorial which explains templates. Basically it is a generalized stack which is already created for us. We don't have to create a separate class and create our own stack. We're just gonna use the predefined stack which is provided in the STL. So that's our goal, because we are here to understand the conversion and not what is stack data structure. We've already covered what is stack data structure and we created our own stack also in other tutorials, so you can watch that. But today's video tutorial's goal is to understand the conversion. So that's why we are using the predefined stack from the STL library. Okay. Now moving on, then we just print the infix expression and then we say postfix is equal to infix to postfix. So this is a user defined function which we will create in a minute now. And this will have the entire algorithm of conversion. We will pass this stack that we created and we will pass this infix expression. So this is the main function which we have to create over here, and this will be the actual algorithm which you can also see in the pseudocode, which will have the entire pseudocode in the form of C++ code. And after that, this function will return the postfix string which will be stored in the postfix string and it will be printed at the end. Okay. So far if I just comment this out and if I just try to run this, I'll say execute, compile and run, things will work properly and we will be prompted to enter an infix expression. So if I say a plus b star c, if I hit enter, I'm getting infix expression is printed as it is, but I'm not getting postfix because we still have to type some code, and only then the postfix expression will have something in it to print. So we have to actually basically create this user defined function. Okay, so far I hope you are understanding. Okay, so let's start off with creating this infix to postfix function, and since you can see it is on the RHS, it is gonna return a string. So the return type of this function will be string. Then I'm just gonna copy this and paste it over here, infix to postfix. Inside this, the very first argument is a stack object, so we will pass that. We will say stack, and it's a character stack, which means that this stack will store character elements into it. That's why you can see in the angular brackets we have char written in it. Let's name it S only, or you can say stack like we have in the pseudocode. And obviously the next parameter is the string itself, which is string infix. Hit enter and create the function. Now obviously the first line in the pseudocode is to actually create the postfix string. So we will say string postfix. Now this postfix string will be ultimately returned from this function, and it will come and it will be stored in this postfix. So if you are confused with the naming, we can rename this to postfix exp. Okay, and let's rename this also as infix exp, which means infix expression, and we'll pass this and this over here. We will also print this. The reason why I'm changing names is so that there is no confusion. Let's change this name to stack, and we will pass stack over here. So in the arguments it would be passed as s and infix, but over here we have changed the names, okay, so that there is no confusion. Okay, so as I mentioned, the last statement has to be return this postfix string, and everything else in between is what we have to do with the pseudocode. So let's see what we have in the pseudocode. Now the second step itself is the loop, which runs from 0 to infix of length, which means we will start from the first character in the infix string and go till the end of the string, because that's where the size would be. So in the for loop we will say for int I equals to 0, I less than infix of length, and we will say I plus plus. So this loop will help us iterate from left to right, from the start character of the infix string to the ending character of the infix string. That's how we scan the entire expression. And inside this for loop, you can see we have 4 different conditions or 4 different parts. These 4 parts represent 4 different types of characters which can come in the infix expression. The point number 1 deals with operands. Operands are basically variables. And if infix of I is an operand, you simply have to add it into the postfix string, and at the end of this entire for loop, this postfix will have all the operands at the start and then operators at the end. So the first condition is for characters basically, right? Operands are basically characters. Characters can be from A to Z in small caps and A to Z in large caps. So when we are converting this pseudocode into programming perspective, we need to think in programming perspective in the way that how the condition will be applied. So when we are saying the first point number 1 deals with operands, it will deal with variables. Variables, as I mentioned, can be characters from A to Z in the small caps and A to Z in the large caps. So how do you check that? How do you check for that condition? So this is how you make that check. You will say if, and then in the condition you will say infix of I is greater than or equal to character A, and infix of I is less than equal to character Z or Z, and then there is a or in between. So this is one condition where we are checking for small cap characters, and then there is a or because we also have capital A to capital Z which we have to check. So we again say infix of I should be greater than equal to A and it should be less than equal to Z. Only then it is an operand, right? Only then it can be considered as a variable or an operand. So this is how programmatically you check for operands, okay? And if this condition is true, the simple thing to do is to simply append that character infix of I to the postfix string by saying postfix plus equal to infix of I. Infix of I would be basically the character which we are at currently scanning in the infix expression, okay? So this is condition number 1, point number 1 in the pseudocode as well. So let me bring this down because the pseudocode image is getting blocked. Anyways, moving on, now we have the second condition. Now the second condition is a else if, which says else if infix of I is equal to, that is equal to a opening bracket. If it is an opening bracket, what do we have to do? So if it is an opening bracket, that is if the infix of I is an opening bracket, what do we have to do? We have to simply take the infix of I and push it onto the stack. So this bracket, that is opening bracket, is pushed onto the stack. So the stack name is S. So we will say s.push and we will say infix of I. Okay, simple. If you're wondering how we got this method, it is because this stack is a predefined stack which is coming from the standard template library. It already has some functions which are related to stack like pop, push, top, and some basic functions which are standard to a stack data structure. Okay, so they are already there, they've made it for us and we are directly using it. Okay, so moving on, we have next condition. So we'll again copy this and we'll paste it over here, and we'll say infix of I is a closing bracket. So if it is a closing bracket, we'll have to do pop and printing the stack till the stack gets empty or opening bracket is found. So just by reading this pseudocode line, that is line number 3 or point number 3, you can understand that it is a iterative pop and print, which means you have to use a loop and you have to keep popping out operators from the stack and printing them in the postfix expression till the stack gets empty or a opening bracket is found, right? So we will use a while loop to achieve this functionality. We will say while s.top, that is whatever is at the top of the stack, is not equal to a opening bracket. So this is condition 1, right? So this is condition 1. Let me add brackets. And the other condition is, so we'll say and again in brackets s.empty, and we will say not s.empty, which means while the top of the stack is not equal to a opening bracket and till the stack is not empty, you keep running this while loop. So in the pseudocode there is a or, but we are using the condition differently. We are saying while the top is not equal to a bracket, that is opening bracket, and the stack is not empty. So if any of the condition becomes false, let's say the top of the stack comes as an opening bracket, so the while loop will exit, right? Because this will become false. We are saying while top of the stack is not equal to opening bracket. So till it is not opening bracket, this condition will always be true. Once we get an opening bracket, this condition will become false, and since there is an AND clause in between, this entire condition will become false and the while loop will stop. Similarly, if you observe this, we are saying not stack empty, which means till the stack is not empty, this condition will always be true. Once the stack becomes empty, this condition will become false and the entire statement will also become false because there is an AND clause. So if any one condition out of the two becomes false, this while loop will stop working. So that's why there is an AND in between and not a OR. So in the pseudocode there is a OR, but the way we've applied or implemented it is slightly different because the condition we've changed, or basically we are using a opposite condition. Okay, so inside this while loop, what do we have? We have to keep on popping and printing the top of the stack and putting it into the postfix expression. So this is how you do that. We will create a temporary character variable temp. We will say s.top. So s.top will return the top of the stack. It will not pop it out. It will not remove it or erase it. It will simply return it and we will store it in temporary character temp. And then that temp will be plus equal to, that is added or appended into the postfix expression. So that operator will go inside the postfix expression. And lastly, we will say s.pop. So this pop function will basically just pop off the top of the stack. It will just remove it. It will not print it. And that's why we had to use this top separately and then pop separately. Okay. So just follow along with me. I am assuming that you guys are typing the code along with me. I highly recommend that you do that because that will give you the best practice. Please do it at least once. I'm obviously going to be sharing this entire code in the video description. You can directly go to our official website and check out this code. But as I mentioned, I highly recommend that you actually type this code out at least once. Okay, so the first if is done, second else if is done, and the third point is also done. Now, if you see the pseudocode, the fourth point deals with if the infix is an operator. The operator can be plus, minus, star, divide by, and raise to. In our case, we are considering only these 5 operators into our program for now, but there can be more operators and then you'll have to change the code slightly. But how do you determine whether the character that we are scanning in the infix of I is an operator? So for that, we will create a separate function. So I'm just going to paste the function and we'll quickly take a look at it because it is fairly easy. So this is the function which says bool is operator. It accepts an argument as a character and it checks if this character is a plus or it is a minus or it is a star, which is multiplication, or it is a divide by, or it is a raise to. If that particular character is any of these 5 different options, we return true, else we return false. Since the return type is bool, it will return true or false. Pretty basic. And we will use this is operator function into our infix to postfix function. And the way we use it is in the last else if, we will say else if is operator, and then we will pass infix of I. So the current character in the infix string that we are scanning, we will pass it as an argument, because obviously is operator accepts a character, right? So infix of I will give you exactly that character that we are at currently, and if it is true, it will return true, and then else if will be executed. So that's how you check whether the infix of I, that is the character that you're scanning in the infix string, is an operator or not. You create a specific and special function for that. Now you can completely ignore this function and else if block as well, and you can directly go ahead with else block also, because logically if you see, our infix expression will only have either opening and closing brackets. For that we have these two conditions. It will either have a operand, so for that we have this if block, if condition, and then the only remaining type of character is a operator, right? So you don't really need to have that condition, but I just showed it to you in case you just need to use it. Okay, so let's use it in our case, but you can go ahead with just the else block for the operators, because ultimately we will be only left out with the operators. Okay, but anyways, this is now point number 4. We are going inside point number 4, which is 4.1. So first thing we check if stack is empty. So again, if s dot empty, what do we have to do? Push infix of I onto the stack. So we will say s dot push infix of I. Simple. Now in the else part, it would be for if stack is not empty. So in the else part, when the stack is not empty, we have again multiple if, else if and else conditions, which basically check the precedence of infix of I, that is the character that we are scanning in the infix string, and the precedence at the top of the stack. So you can see I have used this precedence function, which again is a user defined function. So we have to create this precedence function which will take in a character, that is take in an operator, because ultimately we are in the else if block which is for operators. So whenever we get an operator, we need to go inside this, and when the stack is not empty, we will have to check the precedence of the operator in the infix of I, as well as we have to check the precedence of the operator in the stack of top. So the precedence will be a unique numeric value which will be given to every operator. So we know the precedence rules. So let's quickly create this precedence function over here. Now the precedence function is also going to be basic. Let me just paste it and I'll explain. So it's going to have a return type of int. It will take a character, and if the character is a raise to operator, we will say return 3 because it has the highest precedence. Then in the else if, we say if the character is a star or a divide by, it will return 2 because multiplication and division have the same level of precedence value. So it will return 2. Else if, we will say if c equal to plus or minus, we will return 1 because plus and minus have the same precedence value. And in the else we will say return minus. So when we get a opening or closing bracket, we will get -1, which is the lowest precedence value, right? So numerically speaking, the raise to operator has 3, which is greater than star and divide by, which is 2, which is greater than plus and minus, which is 1, and 1 is greater than -1. So this basically follows the rules of precedence also, right? With the exception being that the opening and closing bracket has got the least precedence, because whenever we get a opening bracket or closing bracket, it does not fall in any of these categories, so it will go in the else block and we will get -1, and that's because we are not considering opening and closing bracket as an operator. Okay, I've explained this in detail in previous tutorial, but yeah, this is the basic user defined precedence function. Now coming back to the else block, we will check if precedence of infix of I is greater than precedence of s dot top. So that's 4.2.1, you can see. In that case, you just push the infix of I onto the stack. So whatever operator we are getting, we are just pushing it onto the stack because it has the higher precedence than the existing top of the stack. The next else if is a unique condition, remember, for the raise to operator. So it says if precedence of infix of I is equal to precedence of s dot top. So the infix of I as well as the s stack of top has the same precedence, which means they are basically the same operator, or they could be star and divide by, or they can be plus and minus. But the next condition, which is a composite condition which has and in between, it checks for infix of I is a raise to operator. So if infix of I and s dot top has the same precedence and infix of I is a raise to operator, obviously the s dot top is also going to be the raise to operator, because only raise to operator has the precedence value of 3, and if infix of I and s dot top has the same values, it would obviously mean that it is a raise to operator only in the s dot top as well. So in that case, again we need to push it onto the stack, right? Remember, that is because for the raise to operator, that is exponent operator, the associativity, when we have multiple raise to operators back to back, the associativity applies from right to left and not left to right. So that's why we want to push all the raise to operators onto the stack first and later on pop them out together, so that we get the proper postfix expression. So that's what we have over here, s.push. Now the last else part will be obviously when the precedence is either less, that is the precedence of infix of I is either less than the precedence of stack of top, or it is equal to the stack of top. So in the else part, we will basically have a loop, because when the precedence of infix of I is less or equal to the top of stack, we simply pop and print the operators from the stack and then check again the infix of I with the new top of the stack. So it's a while loop. So it's a loop basically, and the loop goes as follows. In the loop, there are two conditions, that is the while loop will run till the stack is not empty, so s.empty with a not sign, so not s.empty, and the precedence of infix of I is less than equal to precedence of s.top. As long as the operator in the infix of I that we are scanning in the infix expression has lower precedence or equal precedence to the top of the stack, we will keep on popping the top of the stack. So the top of the stack is stored in the temporary variable, it is passed, that is it is appended in the postfix, and then the top of the stack is popped off. So again the while loop will be executed for the next operator in the top of the stack, which will be again checked with the infix of I. So I hope you are understanding this. We've discussed this in detail in the previous tutorial when we dry ran that pseudocode. So if you are still confused, definitely check that video out. But otherwise this is pretty basic. And this is basically 4.2.3.1 from the pseudocode, the while loop. And then lastly we have 4.2.3.2, which is when this while loop will exit out. It will only exit out if the stack gets empty or the precedence of infix of I is greater than the precedence of top of the stack. So in that case, we simply have to push the new infix of I onto the stack. So this is where we say s.push infix of I. Okay. So this is pretty much the entire else block when you get a proper operator, that is this else if block. And when you come outside this else if block, the only thing left out you can see in the loop also, that is when the loop is completely done, that is we are at end of for loop, which is basically this entire loop over here. After this loop, we simply have to pop and print the remaining operators in the stack. So this is the last instruction in this pseudocode. So how do you do that? We simply use a while loop again while stack is not empty. s.top is directly appended into postfix. So you can also do that instead of using the temporary variable over here. I've used the easy way out. This is not efficient. You don't need to create extra variables. You could have simply or directly used s.top over here and it would still work. But anyways, this last while loop will run till the stack is not empty and it will pop out all the operators from the stack which are remaining, append it into the postfix expression, that is postfix string, and we'll say s.pop. So lastly, after this, we will obviously return postfix from this infix to postfix function, and this is where the function will get over. Okay. So this is the entire infix to postfix function. Let's see if it runs in the first go. We've pretty much typed it all. If you haven't typed it, you can get this entire code from our official website. But as I mentioned, please try to type it for the first time at least. Let's save this and let's try to execute and compile and run. I hope it runs properly. Okay. We've got our output. Now let's see if this function actually works. We will say a plus b star c. Now if you just observe the infix expression and if you know the manual conversion, obviously the expression should look like abc star plus, right? Because the bc happens first, that is b multiplied by c happens first. So the star operator will be first taken to the right of bc, and then we will have a plus bc star. So then plus operator will come. That's how the manual conversion goes. So let's hit enter and let's see if the postfix expression denotes it correctly. And there you go, you can see the postfix expression is exactly right. It is saying ABC star plus, which means that our code is pretty much working fine. But just to be double sure, let's actually input a very complex expression which we actually used into our pseudocode video in the previous tutorial, and let's see if that gets converted into proper postfix expression. I'm gonna again execute, compile and run. So this was that fairly large infix expression. Let's hit enter and let's see if this gets converted to its appropriate postfix format. Okay, we've pretty much got our postfix format, but we are getting these extra brackets. Let's try to analyze why we are getting these extra brackets. Okay, so we forgot one piece of code in the else if when we get infix of I as a closing bracket. So when we get a closing bracket, we keep on executing this while loop till we get an opening bracket or till the stack is empty, right? So if any one of this condition becomes true, our while loop stops. But remember, at the top of the stack, we will still have the opening bracket because we've not yet popped it out. So this extra line of code will check if the top of the stack is equal to opening bracket and pop it out if it is. Okay, so just add this extra if block and your code should work fine. Let's save this, execute, compile and run. Now let's again enter the same infix expression. Hopefully this time the conversion will happen perfectly fine. The conversion did happen right in the previous run also, but we were getting those extra opening brackets. I'm gonna hit enter and there you go. Now you can see in the postfix expression we are getting the exact converted format and it is correct. You can cross check it with the previous tutorial's output. We are getting ABC plus C minus DEF raised to star G divide by. So this is correct conversion of infix to postfix, and we've successfully written a C++ program to make infix to postfix conversion using stack data structure, and this is pretty much possible in any other general purpose programming language also because the pseudocode is gonna be the same. Okay, so that's it for this video guys. I hope you understood the program and I'm assuming now you guys can implement this functionality, implement this stack application yourself, and you can type a code to implement infix to postfix using stack data structure by yourself. If not, please type it and practice it because otherwise you will have a difficult time during the practicals. And this is where I'm going to conclude this tutorial. If you like this video, please give it a thumbs up. Let me know in the comments how this video was. Do share this video with your friends and I'll see you guys in the next one. Peace.